numbers similar to array in the programming depend on the number of dimension it can be take. For example, the scalar, if you see the 5, this is a single number and it's called a 0D tensor. And the scalar vector is a 1D dimension tensor. Matrix is 2-dimension tensor. 3D is called tensor. It's 3-dimension tensor. So this is the real life. 0D tensor is single pixel brightness value of image. 1D tensor is a vector, is the list of daily temperature for a week. Okay. And 2D is the image where each pixel of number. 3D tensor is you colored image, right? So that's called. ND tensor is where each frame with 3D tensor is stacked over the. So this is real life. So why this is important? It's used for deep learning, neural networks, and so on. And efficient computation, Tensor will allow parallel processing, GPU and TPU, Tensor processing unit, graphical processing units, support complex data, handle image, audio, multi-dimension. So it support all kind of data, right? Simple, the Python program, I can do the Tensor like 2 dimension, right? This 1,2 Tensor, so it will print like this. This is 2 dimension matrix, similar to operation apply 1D, 2D. Now the scalar, which I already talked, single digit is matrix called scalar. Vector is either one row or one column. This is vector. I'm going to explain very, very simple. Scalar and vector are basic mathematics, scalar and vector. Both are basic mathematics object in machine learning, AI, and data science. They help computer to understand process number efficiently. So this is already, I said, scalar 0D tensor single number. Definition scalar number is a single number, one value. It has no direction or the size, or just a magnitude. Example, temperature 25 degrees and just a number, no direction. Bank balance 100,000, age 30 years old. In processing, we are doing processing in Python, right? So this is scalar. This is scalar number. Vector is the list of numbers. So definition vector is the list of number arranged in the row, column. It is both magnitude and direction, right? So 3 apple, 2 banana, 1 mango. It can have in the shopping list. You can see like this one. A person height and weight is arranged like 176, 5 cm, 70 kg, 25 years. So he can do like this way. Row of student can be done like this way, right? And so this is, I want to convert into Python, but anyway, it's fine, doesn't matter. So now if you see here, row vector, 2, 7 was one row, multiple columns, right? And the output is like this. In Python programming, I'm going to give you example using NumPy. So NumPy as NP as a row vector, column vector, and this is column vector and number. Why is scalar and vector important? Scalar is used for single value like price, temperature, weight. Vector is used for storing list of value like speed of in different direction, RGB color. Scalar and vector from both foundation, machine learning, deep learning. It's very, very important understanding them in the working of data, AI, and model neural network. So A is upper ladder, and this is called A1, A2. This one, A0. Yeah, you can start from 1 or you can start with a reference by 2 dimension subscripts if you know the mathematics. Understanding simple way, matrix 2 dimension array. So now I'm talking about matrix. First, we talk about scalar, array, so on. Now, matrix, 2 dimension is vector or something. Now, matrix is represent a capital letter A and consists of multiple number of arranged in the rectangular. So if you see here 3 cross 3 matrix, how to read matrix? Each number of matrix called element and entity is rows, column and position. A1 is the first row, first column, A3 to third row, 2 column, real life, image processing, use financial data, table of stock price over the time can be stored. Machine learning dataset with the feature and labels are stored in training, right? So this is how like your 3 cross 3 matrix, right? And this is output, guys. Why matrix is important? It's used in AI and ML. Neural network store the process data using matrix, fast computation, and represent complex data, right? That's why matrix is important. Now this is matrix M cross N cross M, right? N is number of M cross N, number of rows M, N is column. Matrix two-dimensional array, number of rows and column. It's widely used mathematical data science and artificial intelligence. This is same. And matrix addition, like same element we add, like 3, 1, 5, 1, 2, 2, same index we add. It's very simple. Matrix add is we have 2 A and B, like A and B, then like this. This is example. Rule for matrix is simple dimension. Matrix must have the same number of rows and column. Element-wise addition. Each element in the first matrix added in the corresponding element in the second matrix. Real-life image processing, machine learning, AI, finance, physics, engineering, and this is the code of Python A plus B is equal to, right? This is the output. Matrix subtraction is similar to addition, so you do minus and this is what. Matrix subtraction is mathematical operation, right? And it's how it work. It's very simple. Each element of us subtract the corresponding element of the next element. It can be negative. It's very, very simple, right? So key point here, matrix must have same dimension. Subtraction perform on element wise. The output new matrix is the same dimension of the input matrix. Now multiply. So row and column should be equal to, right? 2 scalar multiplied by scalar matrix, right? And in so 2 every element is multiplied. Matrix multiplication with scalar refer to multiply each element of matrix by single number scalar, and this is operation in the matrix given. It's very, very simple. There is nothing harm, right? I'm typing something here, and if you see here, 3 cross 2 matrix, 3 rows and 2 columns, right? And we multiply by 2, so every element works is for any size of matrix. Every element multiply independently, useful for scaling, transforming, computer graphics, physics, like scaling, right? So this is numpy. I want to change Python, but it's not coming my drop down. Maybe I'll change later. That's fine. Scalar like this, original matrix, and if you multiply, then it will become double everything. Matrix multiplication, this is like n into m, right? Or m into whatever you say. This is row, and this is column. First n into m. And this, like these two values should be like n into m, and in. So this row and column, the second column and row should be equal. Then it will become final. So 2 cross 3, 2 rows, 3 column. 2 rows, 3 column. 3 rows, 2 columns. So this 2 should be same. First column, second row same, and then result will be first and last, if you see. Transport matrix is just transforming row to columns. It's very, very simple. There is nothing to harm, right? And if you see the result here, in my diagram article, I have written already, and how it transform numpy array and a dot transform a dot t. T is for transpose, or you can use np dot transpose, right? Key point transpose and use together to numpy the shape of matrix change row to column, column to row. Of course, this is simple. And the transpose is useful for various mathematical coding, solving system equation, performing matrix operation, deep learning application. Now addition, subtraction, transpose, multiplication we have done. Now tensor is mathematical object scalar. This is again, I mean, this is example I give. That's why I put here like single value vector. Like this is like summary of real example 1D, 2D, 2D, and the vector operation did. This is just my, summary. Okay, now let's talk about understanding vector mathematics for machine learning. A vector operation, matrix operation, independent. This is just applications where we use deep learning and so on, right? And the useful tips: use the appropriate type of plot to leverage GPU acceleration, consider memory layouts, right? And related article, my previous article also you guys can read. Core component innovation, addition resource, TensorFlow. So this is very, very important topic, guys. And the same things, if you want to, sorry, if you want to see my code, and this code is here, I have written, I'm going to put into Git. So how we did, so every operation I did, scalar, vector, and matrix, tensor, basic tensor operations, multiply, reshaping, everything. So I'm going to push this code to, you know, Git and giving add to my, you know, Git. I will provide to my Medium channels. Okay, and let's see if it can work. Git push, what it's saying? Git push origin vector. So I need to push this one. And this code is post, and I'm going to share with you guys this code. Should be here. And this is ML. Under ML, I created neural network or AI. No, it should be under AI, I believe. It's under deep learning, ML deep learning. So deep learning is where? ML deep learning. I don't see deep learning here. Maybe I'm using master branch. I should use this branch. And then I can see it's deep learning. Okay, I see, guys, and then vector, and then this is TensorFlow code. It might take some time to appear, but I think I push the code. Should be here. It should be here, guys. It is not here. I need to check. Thank you for watching.